I'm a firm believer that as much as we can get the technologies that make much denser compute more efficient, else we'll be plastering the entire planet with data centers. And the more efficient we can be, the more we can get the balance right between growth in data center demand and so on. So stuff like new technology that has been talking about, like graphene and so on, it's very key for us to meet the increasing demand. So AI is driving increasing demand, and we're already seeing that in what's being highlighted across the globe in growth in demand. Or you're now having AI, hyperscale data centers. That trickles down into what we're doing in Africa. That's why I think our strategy of the core to the edge with open connectivity is a key one to underpin AI. I'll give you an example. You've got an AI engine in the back end of something that's interactive with a customer, and you have latency. Imagine how disruptive that would be in trying to interact with something. So you need to get it out to the edge and make it as real time, milliseconds of milliseconds in efficiency, and in gaming and so on. So AI is going to be very pervasive as a part of the usage scenarios and use cases of how we deliver things. And I believe our core to edge strategy will really support that. But putting AI in perspective, I mentioned I had a role before to Europe, and not far from me was a strategy team working on expert systems. That this was about 35 years ago now.
I was going to say probably like the 90s, because that's when expert systems were in vogue.
Exactly, late 80s into early 90s, really early 90s, talking about expert systems. We were looking at heuristics. We were looking at how to bring intelligence into operating paint shops. That used to be an art of experts, right down into being able to control them with closed loop technologies. Cars, engine management systems, for instance, and so on, has had different elements of AI, but AI has come to a level of maturity that is really quite, I wouldn't say scarily competent. It just puts different levels of functionality for us to be able to use to build and make our lives better, more efficient, greener, and so on, right? Mm-hmm. That net effect of green, as I talked about. So I think AI is going to become much more pervasive. I think it's going to be much more embedded in a lot of what we do. It's going to demand significantly more infrastructure to support it because of the sheer level of compute you need for storage. AI is not AI without underlying data on which you then build on. It's just the underlying data is now global because we have Web3, we have interconnectivity, we have undersea cables all over the place to drive this content around the place. And that data is what's being used, overlaid with what we call AI, right? Mm-hmm. With technology that allows you to do it much quicker, more efficiently, and drive it out to the edge. And that's what we're seeing right now. So the demand for that volume of data to be used is increasing significantly, exponentially, very in a short period of time. The compute that we need to overlay on that data in real time and real-time deliveries increasing significantly. So you now have a lot of the hyperscalers rethinking their engineering per rack, their engineering per device, which are taking different shapes of size, compute per meter squared footprint, increasing significantly. And so you're going to start to see significant cycles of technology refresh increasing, because we now have lots of new use cases coming out because of AI.